Welcome back everyone to the Hello World Guide. This is another episode of the Raycaster series, and in this video we are going to actually implement raycasting against things to complete our shooting mechanism. So currently, if you remembered in the last video, we had shooting kind of working. We refactored our raycasting algorithm and it was working against walls, but now we want it to also work against things. So before we actually get into that, there are a couple of things. So first of all, I have inside of the thing.h function, I have added a new name for the thing, or we should actually call this type. So the thing will actually now store a string called type, which will represent the type of the thing. This will be a member variable in the thing, and each thing definition has a name, a special name. If I open up thing.cpp, for example, what you can see is that here we have got a name for each of these. So for the player, we have got a player, we've got a barrel, we've got pillar, light, and monster. And what this will allow us to do is it will basically allow us to know what type a thing is. When we hit it, we might want to print what type it is. So this would be pretty useful, so I just decided to add that. And yeah, this is pretty awesome. And now if I open up game.cpp, you can see in here when we are creating this thing, we just pass the definition name when we are creating this, and if the player doesn't exist and we are creating the player, we just pass the player like that. So yeah, that's all pretty awesome. So now let's go ahead and open up our raycast.h to actually understand how this works. So rayhit actually now contains another field here, which is a thing pointer called thing, and this thing actually represents the thing that we actually hit, and it will be null if we hit a wall, and if it is not null, then that means that we did not hit a wall, instead we hit a thing. Now this raycast function takes now two new arguments. One is a boolean saying check things, which is by default false, and this basically represents whether we actually want to test against things or not. When we are rendering, we don't want to test against things, but when we are shooting, we do want to test against things. And we have also got a thing pointer here called ignore, which is null pointer, and this will just be a single thing that our raycast is going to ignore. And the reason we added that is because when the player is shooting or any other enemy is shooting, for example, we don't want the enemy to actually be hit by that ray, because the ray does start inside of the enemy. It is possible to actually hit the player or the enemy whenever we shoot it, so that won't work. So that's why we actually take a pointer to a thing which we can then ignore. So now let's go into the implementation of that. So if I open up raycast.cpp, you can see that in here we've got our new function prototype here, and all we do is we do everything less like we did before, but we've got a new thing pointer here called hit thing, and this represents the thing that we hit, and in the end we just pass that into our ray hit as well. So what we do is at the end of this, if our hit, if we actually hit a wall, then that means our check thing is false. So we've got a condition here after we are done with the basic stuff. So either we hit a wall. If we hit a wall, of course we don't want to check against things, or our check things is false. So that means that of course we are told that we should not check against things, and we just continue. Otherwise we go ahead and actually test against the things as well. And in the for loop, now we've got another condition which is saying that not hit thing as well. So as long as we don't hit a wall, we don't reach our maximum depth, and we don't hit a thing, we continue this loop. If we hit a thing, then we stop. So here for the actual thing here, we first of all calculate two things. So the idea is that we are going to use the slab algorithm for actually determining the ray versus AABB collision. It's a pretty well known algorithm. So for that, to kind of speed it up, or actually not speed it up really, just to make it a bit more readable, we are going to use loops, because we need to perform the same calculation on the x and the y axis. But the SFML vector class does not provide a function for an operator actually for accessing it by index, so we can't use it in a for loop. So we just copy the vectors into 2D arrays here, actually not 2D arrays, just 1D arrays with two elements. So we have got this origin here, which is just the position, set to the position, and we have got the inverse of the direction, and we actually calculate the inverse beforehand, because dividing it later would actually be slow compared to multiplying it. So we just invert it ahead of time before we loop over our things. So then we get the block map at the current map cell. We just use map.get block map at the current map position. With that block map, we loop over each of the thing into that block map. If our thing is the same as the ignore thing that we had, then we are going to just continue, because we want to ignore that thing. Otherwise, we are going to calculate the half size of the thing, and then we are going to calculate the start and end. Then we are going to calculate again, we are going to have this as arrays float arrays here, the minimum and the maximum. The minimum is just the start, while the maximum is the end. So this will be the minimum and maximum of our AABB. And then we calculate the tmin and tmax. Here is the actual algorithm thing taking place. The tmin by default is of course 0, and the tmax is the infinity. So we just use std numeric limits float : infinity here. Actually we might not need to do that. I think we do. Yeah, we need to do that. So anyways, we just use infinity here, and then we loop over each of the dimensions basically. So we do 2 dimensions because this is like a 2D world. If you were to do this algorithm in 3D space, you would go loop over 3 times, and we calculate t1 and t2. So the t1 is just the minimum of the current dimension minus the origin multiplied by the direction inverse, which actually means divided by the direction, but since we inverted it earlier, we can just multiply it by the direction inverse, which is slightly faster. And then t2 we do the same thing, but we use max instead. And then tmin we set to the minimum of the t1 and t2 values, and we get the and the resulting value, we get the minimum of that with the tmax value which we have stored here. So on the first time it will always store this value because tmax is infinity. On the second time it might or might not store that, and then we get the maximum value of this tmax that we have calculated, basically all this thing that we have calculated, and get the maximum value of this and tmin, and that we store in our new tmin. And then we do a similar thing for the tmax, but it's just basically the other way. So instead of min we have got max here, and instead of max here we have got min here, and instead of tmin here we have got tmax here, we have got tmin. So this is basically that slab algorithm, and in the end we just if our tmin is less than tmax, then that means that we did hit our array, and if that's the case, then we just set the hit thing to this thing, and if that actually triggers, then this condition here should become false, and it should automatically stop the loop. And that's pretty much all we need to do. So let's go ahead and run this, and hopefully what you should be able to see is that it now allows us to go ahead and actually test against those things. So if I actually wait for it to, yeah, you can see I can go here, and now I can shoot at the wall, and it detects the wall correctly. And by the way, let me open up player.cpp first, and in here you can see that we first check if our hit thing is valid, and if the thing is valid, we just print its actual type, so hit whatever the type is. Otherwise we print just the message like we were doing earlier at hitting the wall. So that's the change here. Anyways, now you can see if I go ahead and shoot at the walls, I can see that it's saying it hit the wall. Now if I actually shoot the pinky, you can see it does say hit a monster, and this time it hits a pillar, and of course the ABB is correct. You can see I can shoot at the pillar, I can shoot at the wall, I can shoot at the pillar, and I can shoot at the wall. Similar for the barrel, and of course it does not detect collision against this because the ABB is basically empty for this one. So the light bulb does have no collision, the barrel does have collision, the monster also has collision, and the pillar also has collision. And since when we are doing the raycast in player, we are passing the player's thing as ignore. That means that whatever we do, our player won't actually be detected in this raycast, and that is very important. So anyways guys, this is gonna be pretty much it for this video. I'll see you in the next one, in which we are gonna start implementing perhaps some enemy behavior, and soon we'll take a look into pathfinding algorithms. It's gonna be pretty fun. So yeah, stay tuned for that. Make sure to like and subscribe as well, and I'll share and make sure to share this video with other people as well. And I'll see you in the next one, and bye.